This is Geometry Chapter 8, the final review. We're going to start off with talking about the objective that students will be able to use the Pythagorean theorem and its converse. So these first three problems says find the missing side, leave your answer in the simplest radical form. Notice that we have right angles on each of these, and you have two of the three sides. So these are just straight up, can you set up the Pythagorean theorem correctly or not? So if I'm looking at the first one, I can see that I don't know this x that's across from the right angle. That's going to be my c. So x squared is going to equal 16 squared plus 12 squared. I'm just going to set up the other three and then have you guys pause the video and figure them out. On the next one, I can see that y is attached to that right angle, which means it's going to be either a or b. I'm going to make it a. 15 is also attached, so that'll be my b, which means 39 has to be my c. I set up the next one, I look z is attached to that right angle, so is the 20, so I go z squared plus 20 squared will equal 28 squared. So what I'd like you to do now is to pause the video and just finish solving these three Pythagorean theorem problems. Alright, so you can see that I have my solutions for the first two up there. I got x is 20 for the first one, y is 36 for the second. The third one for z, you might have gotten to the same stage as I did, that the z squared equals 384, so the square root is, so z equals the square root of 384. But if you try to take that square root of 384, what you end up with is a decimal. And so sometimes that's fine. But if you check the directions on this one, the directions say leave your answer in simplest radical form. So my 19.59591 that I got on my calculator won't work in this case. So if you think back to remembering how we simplified square roots, we started by identifying any perfect squares that could go into 384. My personal favorites to start with are 4 and 9. So I'm going to check, is 384 divisible by 4? It is. We actually get 96. So I can rewrite that as 4 times 96. That's the same as 384. And what I can do is I can pull that 4 apart, and I get the square root of 4 times the square root of 96. And I know the square root of 4 is just 2. So think about the square root of 96, though. Are there any more perfect squares that can go into that? Well, if you know your multiples of 9, you know 9 can't go into it. But maybe 4 can again, because it does end in an even number. And it does. So I might take out another 4. So I get, well, 4 times 24 was the square root of 96. And I can take that 4 out again, it turns into a 2, and I multiply it by the 2 that's already there, and that gets me a 4 times the square root of 24. Think about the square root of 24, though. Any more perfect squares that go into that? Well, I think a 4 goes inside again. It does. So I can pull out another 4, and that turns into the square root of 4 times 6. When I pull that 4 out in front, though, it's the square root of 4, so it becomes a 2. So I get 4 times 2 out in front, which is 8, and I have the square root of 6. So that would be my answer in simplest radical form. We did spend quite a bit of time talking about that in this the second chapter, chapter 8. So this objective also talks about the converse of the Pythagorean theorem. The converse of the Pythagorean theorem essentially says that if a squared plus b squared is c squared, you have a right triangle. But there are also situations where a squared plus b squared does not equal c squared. If for some reason c squared is bigger, it means you have an obtuse triangle. If c squared is smaller, it means you have acute. If c squared is the same, that means you have a right triangle. So what you're going to figure out is, okay, what is this triangle? Acute, obtuse, or right? When you set up this a squared plus b squared as something to c squared, what I like to do is I like to go a squared plus b squared is something to c squared. And I don't know what goes in that circle yet. My recommendation, or my thing that you got to pay attention to is they don't always give you the letters in the order A, B, C. Make sure that C is the biggest number in your list always, okay? So you pause the video and see if you can classify these three triangles using what we wrote over there on the right. Alright, so we should have gotten some numbers like mine. I got 185 is something to 225 here. Well, 225 is bigger. That means c squared was bigger. That means this first one's obtuse. Go to the next one. I got 1681 and 1681. Those are the exact same thing. That means I have a right triangle. C squared's the same. And then I got 365, which is bigger than 361, right here. That means C squared is smaller, so it's acute. So we should have gotten obtuse, right, and then acute. All right, our objective on this slide is that you will be able to use the properties of 45, 45, 90, and 30, 60, 90 triangles. So we're looking for those special right triangles. If you remember, for 45, 45, 90, you might want to sketch this picture. We have a right angle, we have a hypotenuse, and we have legs. And there's a relationship between the side lengths. To go from a leg to a hypotenuse, we multiply by the square root of 2. To go backwards, we divide by the square root of 2. And those are for our 45, 45, 90s, but we also have 30, 60, 90. So for a 30, 60, 90 triangle, draw this picture. We've got a right angle. We've got our little angle up here of 30 degrees, and our big angle down here of 60 degrees. And when this happens, we have what we call a small, medium, and large side. So across from the smallest angle of 30 is your small side. Across from the medium angle of 60 is your medium side. And across from the 90 degrees is your large side. Now the key to all three of these angles, these sides, is the small side. To go back and forth between the small and the large, you use 2. You multiply if you want to get bigger from small to large, and so you multiply, or divide if you want to go smaller. Between the small and the medium side, there's a square root 3 relationship. If you want to get bigger, you multiply. If you want to get smaller, you divide. So let's take a look at these triangles. On this first one, we've got a 45-degree angle, and you can see another 90-degree angle. So we can add in our third angle is also 45 degrees. Right now we have this side of 20. It's across from our right angle, which means it's our hypotenuse. And we have to go backwards to go get our x and our y. So to go backwards, if we check our picture, we're dividing by root 2. So I'm going to take 20 and divide it by square root 2. Now, we're leaving our answers in simplest radical form, so don't just type that into a calculator. What we have to do is rationalize that denominator. We need to get rid of the square root in the bottom. So we multiply by square root 2 because that's going to give us a square root of 4, and that's a perfect square. If you multiply the bottom, we also have to multiply the top. So we get 20 root 2 over the square root of 4. Now we know the square root of 4 is 2, so it's 20 root 2 over 2, which is 10 root 2. Now, in a 45, 45, 90 degree triangle, it's isosceles, 2 angles the same. If the 2 angles are the same, the 2 legs are the same, which means that both x and y are going to be 10 root 2. Okay, we jump over to the next one. This one's a little bit simpler because we're given a 90, we're given a 45, we've got another 45 over here, and we're given 7. Now 7 is one of the legs because it's not across from the right angle. So you need to get both n and m. Well, the legs are the same. So if it's 7 up here, this n, also 7. Once you got the legs, to go to the hypotenuse, you check your steps up above. They say to multiply. So I'm going to take 7 and multiply by the square root of 2. If I do that, I get 7 root 2. And there's no simplifying there. I don't have anything on the bottom. I can't pull anything out. So I get m is 7 root 2, and that's it. Okay, let's go look at our 30, 60, 90 degree triangles. So that relationship is timesing by 2, dividing by 2, multiplying by root 3, dividing by root 3. I look at what I have. I've got a 30 degree, 90 degree. This means this one has to be 60 degree. I'm given a 9. 9, you can see, is across from the 60 degree angle. So this picture is kind of deceiving right now. It looks like 9 is the smallest side. It's not. It's the medium side. Okay. So a better picture for this might look something like this, with a 9, a B, and an A. With our 60 degree angle here on the bottom and our 30 degree angle up here on the top. So we double check. I've got the medium. You always want to go get the small. Small's across from the 30 degrees. So I'm going to go from 9 and figure out B. I double check up above. To go from medium to small, I'm using square root 3. If I want to go smaller, I'm going to divide. So I go 9 divided by square root 3. Now we have to rationalize that again. So I'm going to multiply. I want to turn this square root of 3 into a perfect square. I want to turn it into 3 squared, which is 9. So I'm going to multiply by the square root of 3. I do the same thing on the top. I get 9 root 3 over the square root of 9. Now we know the square root of 9. That's 3. So I get 9 root 3 over 3. I can simplify the 9 over 3, and I just get 3 root 3. So now I have my b value to be 3 root 3. I'm ready to go get my a value. From small to large, we multiply by 2. So I'm going to take that. When I multiply by 2, I'm only going to multiply the 3 out in front by 2, not in the square root. And so I get 6 root 3. Okay, we jump on to the next one. We need q and r. So I'm going to say q equals and r equals. You can see we have a 90-degree angle, or sorry, a 60, a 90, and this is a 30. So this picture looks a little bit better because that 30-degree angle looks the smallest. So right now I've got a 42, which is across from the 90. That means this is my large side. I have to go get my small side. Small is across from my 30. That's going to be down here at my q. To go to large to small, I divide by 2. So I'm going to take 42, divided that by 2, and I get 21. I do the same thing. I do a similar process to get from q to r. Except for this time I want to get bigger, so I'm going to multiply, and the relationship here is square root 3, so I multiply by the square root of 3, and I just get 21 root 3. Alright, this is a review of our special right triangles, our 45, 45, 90s, and our 30, 60, 90s. Here's the next objective. After we talked about special right triangles, we then moved into talking about trig and using trig to help us solve. So our trig stuff that we used was the phrase so, katoa. We were able to use those to identify which trig function to use when. And what we use trig for is that to determine side lengths and angle measures in these right triangles. That's what the objective is talking about. So it says find the missing value to the nearest hundredth. If you remember when you set up sine, regular sine, this number on the inside is your angle, and this out here is your ratio. Now, since this is sine, it would be opposite to the hypotenuse. So if you had a picture, 5 would be the opposite side to the angle, and 15 would be the hypotenuse. Now, when we were trying to solve for that angle measure that we didn't know, we didn't use regular sine. We actually had to change it and use sine inverse. And then with the number that goes inside the parentheses is actually the ratio. The ratio and the x, they switch places, and we go 5 over 15. Now I'm going to pull up a graphing calculator and show you how to type that in. So here's my graphing calculator. Sine is this button right that I just clicked. It's showing up in red, but we don't want sine, we want sine inverse. So instead we hit second sine again, and see how that -1 has popped up? That's our inverse sine. And now we just type in that ratio. The ratio was 5 to 15, and we hit enter. If you get something like this that doesn't make sense, that means your calculator is in the wrong mode. So watch the red buttons where you get the mode clicked. So up at the top it says second mode, so I hit the mode. I go down 3 to where it says radians, where my flashing black cursor is. I go over to degree, and I hit enter. Now if I try that again, I second quit out of there. I go sine inverse of 5 divided by 15. I should get a number that makes a little bit more sense, 19.47. That would be your angle measure then. So we write that in degrees. It says round to the nearest hundredth. So we're going to say that x equals 19.47. You pause the video and try the next one on your own. You can check your answer with mine. I got the angle to be 66.42 degrees. So on this next one, all we're just checking is, can you set up the ratios for these different angles? We're not asking you to find how much the angles measures are, just set up the ratios. So that's just setting up sine of angle A is going to equal the opposite to the hypotenuse. I got that from so, ka, toa. Now what you're looking for is what is the opposite side and what is the hypotenuse side. So I always like to mark my angle, and I go, okay, well, opposite, that one across, that's going to be here. Hypotenuse is that one across from the right angle. That doesn't change. That's going to be 25. So it's just going to be 24 over 25. And you're going to do the same thing for cosine and tangent. Now there's a trick when you get to tangent. Let's see if you can catch it. Pause the video here and try the next two on your own. Your cosine of the angle should be 7 to 25, and your tangent of angle B, they switched angles on you, should be 7 over 24. So if you put 24 over 7, you didn't pay attention to the fact that the angle changed for tangent. All right? So what you're going to do next is you're going to move down to these next ones, and you're going to find the values of y. You're going to round your answer to the nearest tenth. So this is where all those trig skills come into play. You look at the triangle, you mark your angle, and you look at your sides. Well, y is opposite, and 18 is the hypotenuse. So if I think of SOHCAHTOA, I have to determine which one uses the opposite and the hypotenuse. That's so. So I go sine. Now, regular sine uses the angle measure. We have the angle measure of 41 degrees, so we just plug that in. And that equals the opposite side y to the hypotenuse 18. And we essentially just want to solve that equation for y. So if I'm dividing by 18, I would just multiply both sides by it. And y is just going to equal 18 sine of 41. Now you've got a calculator. You go type that in. So watch me type that in. You can type it in with me. I'm just going to type in 18. And then I go just regular sine. And then in there I put the angle measure 41. Hit enter. I get 11.809. It wants me to round to the nearest tenth. I'm going to round that to 11.8. So y equals 11.8. You try to set up and solve the next one. You might have gotten to this point and been like, well, what do I do next? I can't just multiply both sides by 9 because y is in the bottom this time. So essentially what happens is that the cosine of 53, the whole thing, and the y switch places. Because you're going to multiply both sides by y and then divide by cosine. So essentially we're just going to say y equals 9 divided by cosine of 53. And you just got to type that in. So we go back to our calculator. We go 9 divided by cosine, that's right next to the sine button, 53. We hit enter. We get our side. It's 14.95. When we round that, we would say y is about 15.0. Okay, so after we started to introduce sine, cosine, and tangent, we started to do application problems with them, like this one. So students will be able to use sine, cosine, tangent ratios to determine side lengths and angle measures in right triangles. So we had like a whole worksheet actually of word problems, and this one talks about a tree. So the tree's shadow is 72 feet long. The angle of elevation from the ground to the tree is 38 degrees. That's this angle down here. Angle of elevation is how much you're looking up. It says, how tall is the tree? Well, this is the height of the tree. We're going to call that x. Once again, just like the two pictures beforehand, we just have to figure out which trig function is set up. So we look at the sides in regards to the angles. Well, 72 is adjacent, 30, and x is opposite. Opposite and adjacent is my tangent. And I go, oh, do I know the angle? Because if I do, I use regular. If I don't, I use inverse. The angle's 38, so I know it. And then I just go opposite x. Adjacent 72, and I just continue to solve from there. I'd multiply both sides by that 72, and I would get x equals, I can go type it in, 72 tangent of 38, enter, and I get it to be that the tree is 56.25 feet. And it tells me to, doesn't tell me what to round to, so I'm just going to put 56.3. 56.3, now this was a word problem. You're talking about the height of the tree, so you should talk about, well, how tall it is. In regards to a unit, it's feet. So you would say 56.3 feet. Here are two problems where it says find the value of x round to the nearest degree. So these are trig problems again, but the trick on these ones is that you actually don't know the angle measure. So instead of setting up your tangent or your sine or your cosine, you're going to set up those inverses again. So why don't you pause the video and try these two on your own. So these are what I set up. I set up sine for the first one, a sine inverse, and tangent inverse for the second. When I type it in, it does say around to the nearest degree, so I'm going to get that x equals, and I got 35.68, so it's going to become 36 degrees. And for the second one, I type it in, I get 29.74, so that's going to round to 30 degrees. All right. So after that, we started to talk even more about word problems using angles of elevation and angle of depression. And so on these ones, we don't have a picture. And so what you really want to make sure you take the time to do is to make a picture to go along with it. So it says you would lean a ladder 6.7 meters long against the wall. So here's my wall, here's the ground, here's my ladder. My ladder's 6.7 meters. And if you think about it, the wall and the ground usually make a right angle. So I can put that there. The ladder, makes a 63-degree angle with the ground. So I look, ladder's here, ground's here. That's going to be 63 degrees. How high up is the top of the ladder? Well, they want to know how high up it is. That's the height, x. So we're once again just getting to the picture so we can set up a trig function. I look, I have my opposite, I have my hypotenuse, that's my sine. I know the angle, so I can plug it in. It equals the opposite over the hypotenuse. I multiply both sides by that bottom. I don't have to do any switching this time. And I can get my x. I just go 6.7 sine of 63. And we should get it to be about 5.969. It doesn't tell us what's round to. I'm going to give it just 2 decimal places to be safe. 5.97. Now, it didn't ask us what x is. It asks us how high the ladder is. So when we write our answer, we should definitely give it a label because this is talking about how tall and how long things are. So meters is the label they used originally. That's what I'm going to use again. This next picture is a little bit tricky. It's talking about a submarine. So you have a sub and it starts at the surface of the ocean. So here's the surface of my ocean. And then it's going to make an emergency dive. It's going to go down. And its path makes a 21-degree angle with the surface. So it's not just going straight down, it's coming down at an angle of 21 degrees. It's called an angle of depression. If it goes for 300 meters, this is the path it's on. It goes 300 meters. How deep will it be? Well, that's this value right here. Let's call that y. And then, what horizontal distance is it from its starting point? Let's call that x. If you think about the depth and the surface should make a right angle. And we just have to set up 2 different trig functions and solve for both variables. So I want you to pause the video now and try to solve for both variables. If you check your solutions with mine, you can see I got x to be 280.07 meters and y to be 129.01 meters. That's a mistake. Let me pause and fix that one. I made a typo. I couldn't read my own handwriting. I thought I had written a 360 there, but if I use a 300, my y should be 107.51 meters. That makes more sense. And then we have to label our horizontal distance. That was the x, 280, and our vertical distance, that was the y, 107. All right, this last objective is that students will be able to describe vectors in a vector direction. So it says describe each vector as an ordered pair, round the answer to the nearest tenth. So when you describe it as an ordered pair, that means you need an x value and a y value. So here's going to be your x, here's going to be your y value. And so what you're really looking for is the xy value of that end point of the vector. So what you want to typically do is you want to make a right triangle. So I would bring this maybe up to the x-axis. That's what I usually do. And then you can look that you have an angle of your right triangle, and I can put a right angle there, and I have a side of 42, that's this entire side length, and I have 2 sides I'm looking for. So I think, well, x is the horizontal distance, that'll be here, and y is the vertical distance there. And then essentially at this point, what you do is you just set up the trig functions and you solve for x and y. So I look at maybe x is adjacent, 42 is hypotenuse, that tells me cosine. I go cosine of 28 equals the adjacent over the hypotenuse. I'll solve that one in a second. I can do a similar thing with y. Y is the opposite. I have the hypotenuse. So I can go sine of 28 equals the opposite over 42. In both of these two, I'm going to just multiply by 42. Multiply by 42. And then just grab a calculator, type them in, and we should get some values out. X, we should be getting 19.7. And y, we should be getting 37.1. So you can put those into our ordered pair, but we still have one more step left in our ordered pair. Because we are talking in the coordinate plane, you have to think about the positives and negatives of that value. If I'm looking here, well, x when it moves to the left is negative, so I put a negative, and y is negative when it moves down, so I have to put a negative as well. And then that is going to be my final answer. You can pause the video here and try the one to the right on your own. All right, I drew in my triangle, I marked my angle. My right angle is right there in blue. It'll draw, there we go. I set up cosine for x, sine for y, solved them, and I got the same answer for both of them, 46.0. It's really 45.96, but that rounds to 46.0. And then, if you think about it, x is positive when it moves to the right, and y is positive when it moves up, so we don't have to add any negatives to our picture. So the last thing we have for you is here, it says use compass directions to describe the direction of the vector. So this is where we talk about something being north, south, east, or west. And so when we write this, we write some angle, some degrees, something of something. So we start with our angle. Well, it's 55 degrees. We can put that in. And then the second one is the compass direction you put in that the angle is attached to. So the angle goes off like this, but it's attached to the east. So we put our east here, and then we put the second direction that it goes. Well, it's going north of east. We put that first. All right, you pause the video and you try the next one. You can check your answer. I got 20 degrees west of south. All right, well, that was chapter 8, all about triangles, right triangles, special right triangles, and vectors.